Hello, my Algebra 2 students. Let's do some exponent practice today. So the first three really focus right in on the negative exponents. And so I wanted to start by just reminding you of what that rule is. So there's two rules. Same thing, but sometimes it helps to see it separate. The first one is if I have something raised to the negative exponent, it's the same as writing it as 1 over that now raised to the positive exponent. If what I'm raising to a negative exponent is already a fraction, it's a good reminder to think of it as just taking the reciprocal and then raising it to that positive exponent. So both do the same thing, just slightly different way to write it. So the first three that you have right here, if I have 2 to the negative third power, there's that first rule. So I'm going to flip it over, so I put it under 1, and then make it 1 over 2 raised to the third power. And then you can use your calculator if needed, but 2 cubed is 8. And there we go. And now keep in mind, on your calculator, you can do 2 and raise it to the negative third power. It'll give you a decimal. And then you can math frac it to double check your answer there. Right? So that'll confirm that 1/8 for your answer. Otherwise, try it without your calculator. So this one's already in fraction form. So now we make it 4/3 and now raise it to the positive second power. And then remember, that means I can square each piece of it. So 4 squared, 16, 3 squared, 9. And there you go. And feel free to use your calculator to confirm if it's helpful. Otherwise, you got one last one, already in fraction form. Flip it on over and then cube it, which means we're going to cube the numerator, cube the denominator. So 2 cubed is 8. 5 times 5 times 5 is 125. And then there's our answer there. So remind yourself that when we start using variables, still the same rules. So with all of this, when it says simplify and express with positive exponents, there's technically many ways you can do it. To try to keep it consistent so you feel like you have something that you can use as a general rule, I would say deal with any negative exponents first. So meaning, take the reciprocal if needed. And then second, work through simplifying. So combining like terms and so on. So if I take my own advice right here and try this very first one, to deal with the negative exponent first means I would take this and flip it on over. That would make it 1 over x to the positive second. And then I'm going to raise that whole thing to the fourth power. Right? That means I do 1 to the fourth power, and I do x to the second raised to the fourth power. Well, no matter how many times you multiply 1 by itself, it's still 1. And then here, power raised to a power, you multiply. For argument's sake, if you had done power raised to a power first, this would have given us x to the negative 8th power, and then you could flip it over. So whichever way makes most sense to you, you can approach it. But just know that one way or the other, you have to deal with that reciprocal to get that negative exponent out of there. All right, for the next one, same thing. If I deal with the negative exponent first, this is a really great example to see where you have to pay attention to what's being raised to the negative exponent. So it's just this top part. So that's what's going to move. Now it's already in a fraction. So all I'm going to do is move it to the other part of the fraction. So that x to the negative second will drop to the denominator and become x to the positive second. And it's going to join the x to the fourth. Up top, what's left up there is now just a 1. And so if I'm multiplying x squared times x to the fourth, add my exponents, I get x to the sixth. That's going to be my answer there. All right. Let's try one that's a little more complicated. Number 6, to deal with the negative exponent first, just move anything that is raised to a negative power into the other part of the fraction. So what I mean by that, I have an a to the negative first power here and a b to the negative third, right? So they're kind of like my naughty students. I'm going to move their seats. Everybody else can stay right where they are. So that means the 36 b to the fifth doesn't move. The 27 a to the second doesn't move. But that a to the negative first in the numerator will drop to the denominator and become a to the positive first. B to the negative third, I'm going to move up top and make it b to the positive third. Now I can go ahead and kind of simplify and clean things up. So at this point, 36 over 27, I can break that into 9 times 4, and then 9 times 3. B to the fifth times b cubed gives me b to the eighth. A squared times a to the first gives me a cubed. And I can just simplify this part out. So 4b to the eighth, and then over 3a cubed should be my final answer for that one. All right, this next one is a great one to look at. There's a lot going on here. So you have to kind of make a decision as to where you want to start. Do I want to deal with the negative exponent on the inside or on the outside first? Both are correct. I'm going to start on the inside. If I deal with the negative exponent on the inside, it just means in the parentheses, I'm just going to shimmy that x to the negative second down to the denominator. So I'm going to leave a 3y cubed up top. I'm going to leave the 6z in the bottom, and I'm going to bring that x squared down to join it. And now all of that is still raised to the negative second power. Now I'm going to deal with the negative on the outside. I'm going to flip the whole thing over. So that 6z x squared comes into the numerator. 3y cubed goes to the denominator. And now I can raise it to the positive second power. All right, now we got to square the heck out of everything. So 6 squared z squared x squared squared, and then over 3 squared, and then y cubed squared. Now, do you really have to show me all that? No, you could do this step in your head. So 6 squared is 36. Z squared is z squared. X to the second squared is x to the fourth. And then in the denominator, we're going to get 9. This will give me then y to the sixth power, because power raised to a power. And then last thing, I almost forgot. I can simplify 36 and 9. 36 divided by 9 is just 4. So I'm going to have 4z to the second, x to the fourth, and then over y to the sixth power. All right, number 8's got some stars next to it. Let's save this one to talk about in class. And then number 9 is the last one we're going to do in the notes right here. It says, use the properties of exponents to rewrite this in the form of k times x to the n power. So k is just a constant, as well as n is just a constant, right? So the first part, if we rewrite it in that format, that's code for, let's simplify this thing, get rid of that negative exponent. So then 9 over 2x raised to the negative third power. I'm going to take that whole expression and bring it up to the numerator. So it's going to be 9 and then times 2x, that quantity, cubed. The denominator that I'm left with is now just 1 all by itself. So I can essentially just ignore it. All right, this becomes 9 times 2 cubed times x cubed. Well, this is 9 times 8, so that'll give me 72. And then x to the third power. That's the first part. This is considered the kx to the n part. All right. Then it says evaluate for the given value of x. So if we now plug in that x equaling negative 1/3, you can grab a calculator. You can do it in your head. It's up to you. So I'm going to have negative 1 cubed. And then I'm going to have the 3 cubed. So 72 times negative 1 and then over 27. Oof, that's going to be a little bit funky to deal with. Those are both divisible by 9. But here's where you can absolutely grab your calculator and math frack it if you like. So I'm going to have negative 8/3 as my final answer there. All right. Thanks so much for watching, guys. We'll pick up the rest in class tomorrow.